In this morning's weather forecast, I was talking a lot about the blizzard warnings that's basically stretching over the entire Sierra, and then even a few locations that have avalanche warnings as well. And I caught myself thinking about the fact that I don't actually know the science behind blizzards or avalanches that well, so I figured that'd probably be a good thing to learn throughout the day today, and figured I could do that live so you could learn it as well. So we'll just dive in here. What is the science behind blizzards and avalanches? So just going to Meteorology Insider, we see blizzards and avalanches are two of the most deadly natural disasters on the planet. I did look up one fact. I believe it said about 30 people in the US die on average per year because of avalanches. Not sure about blizzards. I'm sure that statistic gets a little shakier because it's a little more difficult to classify, although this does explain the classification of a blizzard, which we're about to learn. So the combination of high winds, low visibility, and heavy snowfall can create life-threatening situation for those caught in a blizzard. Similarly, avalanches can occur suddenly and with little warning, burying anyone in their path under tons of snow and ice. In this blog post, we'll take a look at the science behind blizzards and avalanches to understand how these phenomena occur and what makes them so dangerous. So right off the bat, it starts to explain the difference between a blizzard and avalanche. Anybody who's seen footage of these kind of has a general idea. Blizzard seems to have those whiteout conditions where it looks very snowy and windy, whereas an avalanche, that looks like the side of a mountain is just falling down. And some of the most amazing skiing and snowboarding videos out there, I should maybe choose my words right on amazing, because it's also extremely dangerous, but it's where you see a snowboarder or skier trigger an avalanche, and then they're racing down the hill to outrun it. Just incredible, but also very scary, because you can imagine avalanches can travel up to 80 miles per hour. So if you get one of those very fast-moving slab avalanches, the slab avalanche, it's kind of hard to say, slab avalanche. If you have one of those can be the most dangerous because it's the massive amount of snow moving very quickly. So let's just dive into blizzards first, and then we'll look at avalanches second. A blizzard, here's the classification. A blizzard is a severe winter storm that combines high winds, low visibility, and heavy snowfall. To be classified as a blizzard, a storm must have sustained winds of at least 35 miles per hour. Doesn't sound like that much, but sustained winds of 35 miles per hour will often mean you have gusts up to 50, 60, maybe even more. Sustained is like the average across time, and then gust is just if you were outside and you feel one burst of wind, but it only lasts maybe a couple seconds, that would be your wind gust, versus sustained, which is like the constant wind. So classifying a blizzard, sustained winds of at least 35 miles per hour and visibility of less than a quarter of a mile for at least 3 hours. So to be classified a blizzard, it has to last for 3 hours. You can't just have 35 mile per hour sustained winds and low visibility for 5 minutes and call it a blizzard. So blizzards can form when a low pressure system moves across a region, bringing with it cold air and moisture from the ocean or other bodies of water. Kind of like the low that we have moving into California right now, which is covering the entire Sierra in a blizzard warning. As the cold air and moisture collide, they form snowflakes, which then fall to the ground. If the winds are strong enough, the snowflakes can be picked up and blown around, creating a whiteout condition where visibility is severely reduced. This can make it difficult for people to see where they are going, and it can be easy to become disoriented or lost. So we covered a fair bit of information just in that one little paragraph right there. You often have the worst blizzard conditions at a cold front. That's where I've actually made a previous video on this. You could look back at my channel to find that one, but I can also just explain it here real quick. As a cold front's moving in, it has a very steep boundary, and the cold air is denser than the warm, moist air that it's replacing. So the warm, moist air is pushed up. As it's pushed up, it expands and cools down, literally because the little air particles aren't bouncing into each other as much, so the temperature decreases. And then cold air can't hold as much water vapor as warm air, so some of the water vapor turns into liquid droplets, you get a cloud, and then if it's very cold out, as that cold air is moving in, some of that precipitation falls as snow. And then there's also a very big pressure difference between your cold and warm air. That's one of the signifying factors of a cold front is that pressure difference between the two different density airs. And then when you have high pressure difference, you also get very gusty winds. So that's two of our factors there. You're dropping a lot of snow, but then you also have winds moving it around, which is creating the whiteout conditions. You can also get what's called a ground blizzard, where it's not even snowing anymore, but it's so windy out that it's picking up previous snow and then moving that around for 3 hours. So interesting, you can get a blizzard without it actually still snowing. That was something I learned today when I was doing a little bit of research for this video. So blizzards can be dangerous for a number of reasons. First, the high winds and heavy snowfall can make it difficult to travel or even move around outside. This can be especially dangerous for people who are not properly dressed for the weather or who become stranded in their cars or other locations. Man, I'd probably be the exact kind of person who would get surprised by a blizzard. And it's kind of ironic saying as a weatherman, but I'm kind of one of those people where I look outside and it looks sunny, so I just think that it's warm and I wear shorts. And the last time I was going up to Tahoe, I looked at the forecast and it showed sunshine. And I was like, I'll rock some shorts up there. And then we get there and of course it's like 28 degrees or something. So moral of that story, dress warm when you go to the mountains, especially if there's a blizzard warning in place. So second, blizzards can cause power outages, which can leave people without heat or light for extended periods of time. This can be particularly dangerous for those who are elderly, sick, or otherwise vulnerable. That's a pretty big thing to think about there, because if you have blizzards, one of the factors that you use to classify a blizzard is high winds. And when you get high winds, that can knock down branches, trees, which take out power lines, and knock out the energy source that is providing the heat that people need when you have the conditions that are cold enough to create the other part of the blizzard, which is snowfall. So a lot going on right there. I think we learned a fair bit about blizzards. Let's now move on to avalanches. An avalanche is a mass of snow, ice, and debris that slides down a mountainside. Avalanches can occur when a layer of snow becomes unstable and starts to slide, picking up more snow and ice as it goes. They can be triggered by a number of factors, including heavy snowfall, high winds, and changes in temperature. I think we can also add on skiers, snowboarders, snowmobiles. I think those are the factors that trigger the largest amount of fatal avalanches, because that's where people are actually present. But it's also interesting that it talks about the different layers. So I've heard about this before. If you have like there's two different classifications of avalanches. I believe it's called slough avalanche, which is just a smaller amount of snow, and then slab avalanche, where it looks like the whole mountain is coming off. And a lot of times slab avalanches will happen where you've had a previous snowpack that's been able to compact, and then you maybe get what's called, I think it's called hoarfrost on top of it, and it creates a weak layer, and then you pick up more snowfall on top of that, but there's this weak layer between the compacted snow and the new snow on top, and then something can trigger it and it's able to fall down. So continuing, avalanches can be deadly for several reasons. First, the sheer force of the snow and ice can crush and bury anything in its path. Second, the weight of the snow can make it difficult for people to move or breathe, especially if they are buried beneath it. Can't imagine anything scarier than being buried by an avalanche. Well, maybe a few things, but that's up there with things that you don't want to happen. So to avoid being caught in an avalanche, it's important to understand the conditions that can cause one. Avalanche danger is typically rated on a scale of 1 to 5, with 1 being low danger and 5 being extremely dangerous. Sounds almost like how we classify hurricanes. It's important to pay attention to these ratings and to avoid areas with high avalanche danger. One thing that this didn't mention that I learned earlier today is a big part of avalanches is it matters the slope of the mountain that you're talking about. Most of them happen between 25-degree slopes and 60-degree slopes, with the majority of those being between 35 and 45 degrees. And if you just think about this a second, it makes sense. If it's flat, you're not going to get that big sliding action. But then if it's too steep, you're also not going to be able to pile up enough snow in order to have an avalanche. So it's that little middle ground where almost 45 degrees is where you're seeing the majority of avalanches. One other interesting thing I learned this morning was it's surprisingly on the leeward side of mountains that you see the majority of avalanches. This completely surprised me because I would have thought windward side, because that's where you're getting the largest amount of snow. If you don't understand that, you can look up the video I did on the rain shadow effect. So majority of the lifting happens on the windward side. So that's where you get the majority of your precipitation. And then on the leeward side, it's usually a fair bit drier. But what I learned this morning is that the winds will actually blow some of the snow over the top onto the leeward side and create almost this ledge of snow that's able to fall and turn into an avalanche. So when you think about it that way, it actually makes sense, where you can get this big chunk of snow building up on the top of a mountain and not as much snow underneath it supporting it. So with less support, falls down, you get an avalanche. All right, so conclusion, blizzards and avalanches are two of the most destructive and deadly forms of winter weather. Blizzards and avalanches are dangerous due to their ability to cause road closures, power outages, and extreme cold temperatures, as well as their ability to bury entire villages and cause hazardous conditions for skiers and hikers. And then when it comes to blizzards, the classification is 35 mile per hour sustained winds and visibility less than a quarter of a mile for 3 hours. And then how you could think of it is you just have a lot of snow. It's being moved around by the winds, creates whiteout conditions, extremely dangerous for any kind of driving, travel, or just dangerous in general. And then with avalanches, most of those happen on your 35 to 45 degree slopes where snow is able to build up, especially if there's a weak layer separating the new snow from kind of almost a bed layer below it. You could think of it that way. And then a number of different things can trigger it, but then when it triggers, you just see a large amount of snow all coming down at once, and I don't really need to explain why that would be dangerous. So hopefully this video was helpful. I know I certainly learned a lot throughout the day today making this, and more science and weather information coming every single day, Monday through Friday. Thanks for watching.